gosh! I don't understand any of this. What is Euler's method? Why is it pronounced Euler's and not Euler's? Just focus on your calculus, Amir. Those jerks. I wish my mother was here. Oh, where am I? What is this book? B squared secrets revealed? Is this the Narnia Chronicles? Oh! I'm subdued! It's a video!
Hello, Amir.
Hello.
Haha! You think you're a slick cricket, don't you, buddy? Managing to steal our book.
That's not just any book. That's B squared secrets revealed.
Well, you're not slick.
We've got you trapped, and we're coming. We are at point 21, and we're traveling at a rate of dy dx equals 2x minus y.
Holy cow! Think! Brain blast! Euler's method!
Let dy dx equals 2x minus y be the differential equation for the y equals f of x equation with a point 21. Using Euler's method, approximate y of 3 using two intervals of equal width. Alright, so the first thing we want to do is find y of 1. So we're basically dividing the problem into two different parts. We're trying to find y of 1 right now, and the equation of that is use the y of 0 plus dy dx with the points 2, 1 times delta x, which in this specific question is 0.5. So now plugging in all the numbers, we get 1 plus 3 times 1/2, which gives you 5/2. That's the first part of the problem. So now we're going to find the second part of the problem. We're going to take y of 1 now that we just got, which is 5/2, plus dy dx at that point 5/2 times delta x again, which is again 1/2. Alright, so plugging in the points, we get 5/2 plus 5/2 times 1/2, that was the delta x, which equals 15/4. So our final answer, y of 3 equals 15/4. And that's how you do the problem.
Okay, I might have enough time to escape. It's another video!
Haha, we lied. We're not actually at the previous point. We're at point 11 traveling at dy dx equals 3x plus y.
Haha! You'll never get away, you sneaky goose.
Alright, time for the second problem. Let dy dx equals 3x plus y be the differential equation for the y equals f of x equation with the point 11. Using Euler's method, approximate y of 2 using two intervals of equal width. Alright, so we're again going to divide this problem into two different parts. First we're going to find y of 1, and to do that we're going to take y of 0, which I already gave us, plus dy dx at the point 1 times delta x, which in this case is 1/2. So we're going to plug in our numbers. We get 1 plus 4 times 0.5, which gives us 3. So we've just done the first part. Now we have to do the second part. Y of 2. To find that, we take y of 1, which we just found, plus dy dx at 1.53 times delta x, which is 0.5 again. So plugging in our numbers, we get 3 plus 7.5 times 0.5, which is equal to 6.75. So the final answer, y of 2 equals 6.75.
Oh my gosh, I really have to escape.
little cricket.
How did he? Oh!
How do you escape?
Oh. It's a video from Amir.
You'll never catch me now, you fiends. I'm at point 04, and I'm traveling at dy dx equals y minus 2.
How are we supposed to catch him now?
Think. Euler's method.
I think it's pronounced Euler's method.
Oh. Using Euler's method with 5 subintervals, approximate y of 1 if dy dx equals y minus 2 and y of 0 equals 4. First, we find y sub 1, we add y sub 0, and plug in the point into dy dx, and then we multiply by the change in x. That comes out to 4.4. We do the same thing for y sub 2, we add y sub 1, and then we plug in the last point into dy dx. We multiply that by the change in x, so it comes out to 4.4, which is y of 1, plus 2.4 times 0.2, and that equals 4.88. We do the same thing for y sub 3. We add the last point, we plug in the last point into dy dx, and then we multiply by the change in x. That comes out to 5.456. For y sub 4, we add y sub 3, which is 5.456, and then we plug in the point 0.6, comma 5.456, which is the last point, into dy dx, and then we multiply that by the change in x. That comes out to 6.1472. For our final step, y sub 5, we add 6.1472. We add that to the point plugged into dy dx, 0.8, comma 6.1472, and that comes out to 4.1472, and we multiply that by the change in x, 0.2. So our final approximation is 6.97664. So y of 1 is approximately equal to 6.97664.
That snake thought he was slick, didn't he?
Well, he's not. We got him now.
Amir Daneshvar, conqueror of the evil villains and their dirty traps. And I still have their book.
Give us the book! Yes! Open it! Open it!
Whoa! It's okay, Amir. It's okay. It was only a dream. It was only a dream.